In this video, I am going to talk about the quantum free electron theory to explain the conductivity of the metal or semiconductors. So here we have to see that in the case of solid, due to the accumulation of atoms, the energy levels split up into multiple energy levels which are very close to each other, leading to the formation of energy bands. So here in this theory, we are going to assume the band nature of energy levels. Now when it comes to electrons occupying these energy levels, it is governed by a principle known as the Pauli's exclusion principle, or it is broadly given by a statistics called as the Fermi Dirac statistics. So let us see now what is the Fermi Dirac statistics. Just like we have Maxwell-Boltzmann statistics to explain the behavior of gas molecules, here we use Fermi Dirac statistics to particles called as fermions, which are having half integral spin. Example for such particle is electrons. So here to describe the distribution of electrons in the energy levels, therefore we have to apply the Fermi Dirac statistics and not the Maxwell-Boltzmann statistics. So what is Fermi Dirac statistics? So in this statistics we are using three important functions. First one is the Fermi factor, denoted by F of E. Second one is the density of energy states, denoted by G of E. And third one is the number density of electrons, which is denoted by N of E, and it is also given by the product of F of E and G of E. Let us see in detail what is these three functions. First, coming to F of E or Fermi factor. This is actually a probability distribution function. It gives us what is the probability of finding an electron in a given energy level E. And we know that the probability values lies between 0 to 1. So this function f of E basically gives us a value between 0 to 1, which is actually giving us the probability that the given energy level E is occupied. And it is given by this formula. F of E is equal to 1 by 1 plus e power of E minus EF by kT. So here we see this term EF is known as the Fermi energy level. And here we also see that this function depends upon the temperature also. The second function, G of E, or the density of energy states. So this tells us how many number of energy levels are available per unit volume around a given energy E, and that is given by this function G of E is equal to some constant C into e power of half. Here the constant C is given by 8 root 2 pi m to the power of 3 by 2 by h cube, where m is the mass of the electron and h is the Planck's constant. The third function, N of E, is the number density of free electrons in the given energy E. It is given by the product of the Fermi factor F of E and the density of states G of E. So this tells us how many number of electrons are available in a given energy E per unit volume. So using these three functions F of E, G of E and N of E, we will be able to explain the conductivity of metals in the quantum free electron theory.